Today we're going to continue talking about geometric sequences and series. We're going to start today by learning how to add up a given number of terms of a geometric sequence. The sum, which means we're adding up the first n terms of a geometric sequence, denoted by S sub n, and called the nth partial sum, can be found without having to add up all the terms. Recall that these are the first terms of a geometric sequence. The sum of those first n terms of a geometric sequence can be found by this formula. To get the sum, you're going to take the first term times 1 minus the common ratio to the number of terms you're adding, and then divide it by 1 minus r. So to use this formula, we need the first term, we need the common ratio, and we need the number of terms. Plug them in, and you got your answer. So it says use the formula for the sum of the first n terms of a geometric sequence to solve. They want me to find the sum of the first 11 terms of this geometric sequence. So I need a sub 1, I need the common ratio, and I need the number of terms. Well, a sub 1 is easy, that's 3. To get your common ratio, divide backwards. Negative 6 divided by 3 is negative 2. And the sum of the first 11 terms, so n is 11. So if I plug them in, the sum of the first 11 terms will be my first term, 3, 1 minus a negative 2 to the 11th over 1 minus a negative 2. Okay, so the sum of the first 11 is going to be 3 minus, the first thing I'm going to do is in parentheses type negative 2 caret 11, and you get 1 minus a negative 2048 all over 1 minus a negative 2. The double negatives turn positive. And I get 3 times 2049 over 3. Those cancel, and the sum of the first 11 terms is 2049. Okay? Don't freak out on fractions. Same process. Okay, so we need a sub 1, we need the common ratio, and we need the number of terms. A sub 1 is 3 halves. To get my common ratio, I'm going to divide the second by the first. Keep, change, flip, those cancel. I get 2 over 4, which is 1 half. And the number of terms, they want the sum of the first 5. So the sum of the first 5 will be the first, 3 halves. And I know you hate fractions, so make that a decimal, 1.5. Parentheses, 1 minus 0.5 to the 5th over 1 minus 0.5. Okay, so if I do 0.5 caret 5, I get 0.03125. Sorry, I don't know why my pen's making all those marks. 0.03125. So if I do 1 minus that, 1 minus 0.03125. I get 0.96875. So I have 1.5 times 0.96875 over 0.5. So if I type that, 1.5 times 0.96875, enter, divided by 0.5, you get 2.90625, and if you math enter that, if they want it in fraction form, you get 93 over 32. Okay? Alright, so you try this one, hit pause, come back when you're ready. And hopefully you got 682 over 3. So a sub 1 would be 2/3. My common ratio, I'm going to take 8/3 divided by 2/3. Keep, change, flip, you get 8 over 2, which is 4. And the number of terms, they want the first 5. So the sum of the first 5 will be the first. Don't change that to a decimal because it's a repeater. I mean, you can, but you're going to have to round, which could affect you being able to get the right fraction. So if you're working with a decimal that when you a repeating decimal, don't use the decimal because you have to round. 1 minus 4 to the 5th all over 1 minus 4. So 4 caret 5 is 1024. 1 minus 1024 is negative 1023. 1 minus 4 is negative 3. So now when you type this, just be really careful. I'm going to type 2 divided by 3 times negative 1023, and I get negative 682 on top over negative 3 on bottom. The negatives cancel, and the sum of the first 5 terms is 682 over 3. Okay? Alright, find the following sum. Same concept, they just are writing it differently. They're telling you to sum up the numbers from 1 to 10. So you're adding the first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So your n would be 10. Okay, your a sub 1 we have to figure out. So if I plug in 1 to my formula, I get 6 times 2 to the first, which would be 6 times 2, which would be 12. And they want the sum of the first 10 numbers, yeah? So I got a sub 1, I got n, and my common ratio is 6. They're multiplying by 6 every time, yeah? Oh no, 2, sorry. The base is the base of the exponent is your common ratio. So my ratio is 2. Yeah, remember, because it's the initial term. Right. Yeah, the base of the power is your r. 10 minus 1 is 9 plus 1. Yeah, and remember, if it starts at 1, it's no big deal. Your top number is your n. But if you're not starting at 1, remember, it's going to be the top minus the bottom plus 1, because you got to count that first term. Alright, so if I plug everything in, the sum of the first 10 is going to be a sub 1, which is 12. 1 minus, my common ratio is 2 to the 10th, over 1 minus 2. Okay, so I have 2 caret 10 is 1024. 1 minus that would be negative 1023 over negative 1. So the sum of the first 10 is 12 times negative 1023 divided by negative 1. And you get 12,276. That would be the sum of the first 10 terms of that sequence. Alright, it says find the indicated sum. Use the formula for the sum of the first 10 terms of a geometric sequence. Alright, so we are starting at 1 and going to 3. So n is 3. My first term, I'm going to plug in 1. So I'd have 2 fifths to the 1 plus 1, which would be 2 fifths squared, which would be 4 25ths. Okay, and then what do I need? My common ratio is 2 fifths, the base of the power. So if I plug everything in, the sum of the first 3 is going to be the first, which is 4 25ths, 1 minus 2 fifths to the third over 1 minus 2 fifths. So first of all, type in parentheses 2 divided by 5 parentheses caret 3, and that's 0.064. So 1 minus that is 0.936 over, if I type in 1 minus 2 divided by 5, I get 0.6. So if I simplify that, I'm going to have 4 divided by 25, enter, times 0.936, enter, divided by 0.6, and I get the sum is 0.2496, math enter, enter. The sum of the first 3 is going to be 156 over 625. Alright, you try this one. Hit pause, come back when you're ready. And hopefully you got 592 over 81. So we're going from 1 to 3, which means n is 3. My first term, plug in 1, would be 4/3 to the 1 plus 1, which would be to the second, which would be 16 over 9. And my common ratio is 4/3. So the sum of the first 3 is going to be the first term, 16/9, times 1 minus 4/3 to the third over 1 minus 4/3. So parentheses, 4 divided by 3, parentheses, caret 3. And I get, 2.37 blah, 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 blah. 1 minus that is negative 1.37037,037, that must repeat, over 1 minus 4 divided by 3 is negative 0.333 repeating. So now if I type in 16 divided by 9, enter, times negative 1.370370370, enter, divided by negative 0.333 repeating, I get, math, enter, 592 over 81. When you type these in, guys, you will not get this if you don't, when you have repeaters, when you type them in. Hold on. Let me get my calculator here and I'll show you. All right. Okay, so let me get my calculator up here. So when I'm typing this in, guys, I typed 16 divided by 9 and I hit enter. Then I multiplied by the numerator, so times negative 1.370370,370, and I just keep going until it hits the next line. Well, you can see my arrow, so it gets that I'm repeating. Enter. And then I'm going to divide by negative point, and again I'm going to type the 3's until that either it starts on the next line or it gives you that arrow so it knows it's a repeater. Okay, and you get that, and then math, enter, enter, and there's your 592 over 81. If you rounded these off when you typed them in, it would not have converted it back to a fraction for you. So be very, very careful when you're dealing with repeaters. Okay? Alright, so next. Alright, so how do you find the sum of a finite geometric series? Well, it's S sub n equals a sub 1, 1 minus r to the n over 1 minus r. You find those values and plug them in. Alright, so now an infinite sum, a geometric series, an infinite sum of the form that it's same thing, but it goes on forever and ever. If you're trying to find the sum of an infinite, meaning it doesn't end, okay, there's your formula. Keep in mind, if the absolute value of r is greater than or equal to 1, the infinite series does not have a sum. If your common ratio is bigger than 1, the infinite series, you can add up a finite number of terms, but you can't add up them forever. Alright, so it says find the sum of the infinite geometric series. 3/8, negative 3/16, positive 3/32, negative 3/64, dot, 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 dot. Okay, so I need a sub 1, which is 3/8. To get the common ratio, I'm going to take negative 3/16, I wrote 36, and divide it by 3/8. Keep, change, flip. Wow. The 3's cancel. That leaves me negative 8 over 16, which is negative 1/2. So my absolute value of that would be the absolute value of negative 1/2, which is 1/2, which is not greater than 1, so I'm good to go. So we plug everything in. The sum is going to be the first term, which is 3/8 over 1 minus a negative 1/2. That turns positive. So I have, again, if you want 1 plus 1 divided by 2, it's going to be 1.5. So I have 3/8 over 1.5. So 3 divided by 8, enter, divided by 1.5, enter. You get 0.25. Math enter that. And you get the sum will be 214. Okay? Alright, you try this one. Hit pause. Come back when you're ready. And hopefully you got 27. Alright, a sub 1 is 18. To get my common ratio, 6 divided by 18 is 1/3. So setting it up, the sum is going to be 18 over 1 minus 1/3. If I do 1 minus 1 divided by 3, I get a repeater. So I have 18 over 0.666 repeating. Alright, so if I divide that, 18 divided by 0.666, just hit the 6's until, don't hit the 7 on the end. Let the calculator know it's a repeater. Enter, and you get, oops, I did times, 18 divided by keep the 6's going until it hits the next screen, and I get the sum is 27. Okay? Alright, so do this one. They just wrote it differently. Hit pause. Come back when you're ready. And hopefully you got 40 over 17. Alright, a sub 1, I'm going to have to figure out. So I'm going to substitute 1. So I have 4 times negative 0.7 to the 1 minus 1, which would be to the 0. Which would be this, anything to the 0 is 1, times 4 is 4. So my first term is 4. My common ratio is 0.7, right? Negative 0.7. So when I set this up, the sum is going to be a sub 1 over 1 minus a negative 0.7. That's going to be 4. Oh, 0.7, yeah. So that's going to be 4 divided by 1.7. So type in 4 divided by 1.7. You get 2.352941176. They want a fraction, so math, enter that. And you get 40 over 17. Alright, so to determine whether a sequence is arithmetic, geometric, or neither. If it's arithmetic, then you're going to get the same thing when you keep subtracting your terms backwards. If it's geometric, you're going to get the same thing when you divide backwards. And if it's neither of those, then it's neither. Alright, so determine whether the sequence is arithmetic, geometric, or neither. Obviously it's arithmetic. Obviously it's geometric. Obviously it's both. Okay, but let's see what's going to happen. This one's going to be neither. But if you weren't sure, okay, you could find the first several terms. A sub 1 would be 1 plus 5 is 6. A sub 2 would be 7. Right? 1 plus 5 is 6. 2 plus 5 is 7. A sub 3 would be 8. A sub 4 would be 9. And you can tell from your terms that they're adding 1 every time. If you're adding the same amount every time, that's arithmetic. Okay, for this one, if I find the first several terms, a sub 1 would be 2 to the first, a sub 2 would be 2 squared, a sub 3 would be 2 cubed, 8, a sub 4 would be 2 to the fourth, which is 16. And I can see the pattern, times 2, times 2, times 2, they're getting bigger by multiplying by 2 every time. That's geometric. Okay, over here, if I find a sub 1, it would be 1 squared plus 5, which would be 6. A sub 2 would be 2 squared plus 5 would be 9. A sub 3 would be 3 squared plus 5 would be 14. A sub 4 would be 4 squared plus 5. 16 plus 5 is 21. If I tried to go arithmetic, this would be adding 3. This would be adding 4, 5. This would be adding 7. It's not arithmetic because they're not adding the same thing every time. If I tested for geometric, 9 over 6 would be 3 halves. 14 over 9 is not 3 halves, so it's not geometric, which means this one is neither. Okay? Hit pause, come back when you're ready. It's neither. You can tell because there's a geometric part, there's a multiplier part, there's a subtraction part. This is going to be a mess. But if you tried it, a sub 1 would be 4 times 1 squared minus 3. That would be 4 minus 3 would be 1. A sub 2 would be 4 times 2 squared minus 3. That would be 4 times 4 is 16 minus 3 is 13. A sub 3 would be 4 times 3 squared minus 3. That'd be 9 times 4 is 36 minus 3 is 33. This would be adding 12 and this would be adding 20, so it's not arithmetic. The first quotient would be 13 over 1. The second would be 33 over 13. Those don't equal, so it's not geometric. It's neither. Okay, try this one. Hit pause, come back when you're ready. And it's arithmetic. Okay, so if I find a sub 1, it'd be 3 times 1 minus 2, which would be 1. A sub 2 would be 3 times 2 minus 2. 6 minus 2 is 4. A sub 3 would be 3 times 3 minus 2. 9 minus 2 would be 7. A sub 4 would give me 3 times 4 minus 2. 12 minus 2 is 10. They're adding 3 every time. That's arithmetic. Okay? Find this one. Hit pause. Come back when you're ready. I can tell it's geometric because it's got the power, but you could figure it out. A sub 1 would be 5 to the first is 5. A sub 2 would be 5 squared is 25. A sub 3 would be 5 cubed is 125. The pattern is multiply by 5 every time, so it is geometric with a common ratio of 5. Alright, so we just talked about classifying sequences as arithmetic, geometric, or neither. Alright, so we're at homework, which means we are done. So happy homeworking, and I will see you next time.